And we're back. It looks like there's been a lot of activities on Code Labs, and I've been keeping up with streams from around the community, and they've been so wonderful to watch. For example, Hendrix Taveras in Florida walked us through the introductory experience for Dart and Flutter. And then I caught up with videos released over the last couple of days, like with Matab and Max from Flutter Explained, live coding up some form controls. After the stream here and throughout the weekend, there are events like Flutter Day Turkey run by Beza, Flutter Karachi is having an online quiz, and Women Tech Makers in Saudi Arabia, organized by Mace, is running a content and talks over the next 6 days. There are, of course, so many streams going out throughout the community that I can't list them all, and I hope you're able to catch one that's close to you, whether it's today, tomorrow, or over the coming days. In the meantime, welcome back to this stream. If you're just joining us, hi, thanks for tuning in. You can check out the links in the description below for more information about Flutter Day. In particular, we have a lot of code labs, some new and some refreshed, and they're a great way to gain more experience in a variety of Flutter topics and maybe find some puzzle pieces. But starting right now, Kenzie and Philip talk all about performance and some of the newest features in DevTools, and we'll have them back just after it for a live Q&A. Let's listen in.
Hi, I'm Philip, a developer advocate on the Flutter team, and I'm here today with Kenzie. Hi, Kenzie.
Hey, Philip. I'm Kenzie. I'm a software engineer on the Flutter developer experience team.
Kenzie is actually one of the engineers behind DevTools, and that's what we're talking about today. So, that's fortunate. Kenzie, what are DevTools?
So DevTools is a tooling suite for Flutter and Dart developers consisting of layout inspection tools, performance tools, memory tools, really just all the debugging tools that you need to be an efficient and effective Flutter developer bundled into a single web suite for you.
Cool. So, but DevTools have been around for a while, but what you're showing is a little different.
It is a little different. We actually rewrote the entire suite and added some cool and new features to the tooling suite. And the best part is we rewrote it entirely in Flutter.
So it's Flutter tooling written in Flutter, running in a web browser.
Yes.
Do you use DevTools to debug DevTools, Kenzie?
I do use DevTools to debug DevTools, and it's quite useful.
Awesome. Let's show how you actually get to DevTools. In Android Studio, there's this, if you run your app in either debug or profile, you have this little icon which you can click and it opens up DevTools in your favorite web browser. If I was using VS Code, there's this handy little notification here, but also if I was actually running the app from here, there would be a similar looking icon that I could click. So it's pretty easy to get to. And even if you're running from the command line, there's ways to open it up from the command line, which I will not be doing today. I wanted to show you, I wanted to start with the app that will be trying to kind of debug or troubleshoot today. And the app is called Sloth app, and it's something that I've been using for a while now. It is just terrible. It's full of issues and full of performance inefficiencies and stuff like this. And that is intentional. And so I want to show you how you would use DevTools to like make things right in an app like that. Hopefully your apps are a little better, but so the app is structured like this. I have it here on my phone, and it's just connected to my screen so that you can see it. But the way it's structured is that there's always some issue on every third page of this page view, and the reason for that is just so that the different issues don't interact with each other, so they're separate, right? So let's have a look at the first issue, and that's actually a layout issue. So here you have Flutter is Google's UI tool for building beautiful, and that's cut off, and that's not great. It seems like a layout issue, but maybe I want to look at the code. Maybe it's a little hard to parse what exactly this means. Kenzie, how can DevTools help there?
So to solve this problem, we're going to want to use the Flutter inspector in DevTools, which is our tool for helping you diagnose and debug layout issues and just get an overall understanding of the general layout of your Flutter application. So here we can see I have the same app running that Philip does, and I am running in debug mode, so I can see these errors. And we see the all too familiar caution tape error for render overflows. And we want to use the inspector to figure out why that's happening and how we can fix it. So I have the row selected that contains the Flutter logo and the padding. If I enable that, you can see this is the overall row. And what I can do is look in the summary tree here that gives me just the overall view of my widget hierarchy, find the widget I'm looking for, which is this row, and then jump over to the details side of the inspector, which allows me to look at specific properties for that row, as well as the properties for children of the widget and so forth. So what we could do is look through here and try to look through the render object constraints and see if something's unconstrained or if there's something that we can fix, but that's complicated and not very friendly. So we will use the Layout Explorer, which is a feature that we added to the Flutter version of DevTools, which was just released. And it's an example of where building our own app in Flutter allowed us to build some really cool features that would have been more difficult in the previous version. So in this Layout Explorer, I can tweak certain values of, say, axis alignment or flex values, and I can see the change hot reloaded into my running application. So this allows me to kind of plug and play with different properties and see if there's anything I can fix. So I'm going to play with properties and see if it fixes my problem. That didn't, so I'll put it back. And there we go. The render overflow error goes away. And I now have my text widget in this application, or the padding widget containing the text has a flex value. So the row knows to give the remaining space to that padding widget. And now I can go back to my application and make that change. Does that help, Philip?
Absolutely, yes. Let's actually show how that would work. So I have the code here. It's a Flutter logo and a padding. And then I can just use another DevTool thing, I mean, developer tool thing, which is wrapping the widget. And I can use either flexible or expanded here to give it the flex value that Kenzie did in the UI. And I think the key thing here is that Kenzie could play with it without actually touching the code. And it's, at least for me, it's much more understandable if I see it in the Layout Explorer that, okay, so these children want to take this much time, not this much time, this much width, and they can't because there's just not enough. And you can also see if you click on the padding or text, it's not flexible, which, you know, coming from a different framework, you might be like, oh, but text should be kind of flexible, right? But no, it's by design, it's not, unless you put it into a flexible widget, like expanded or flexible here. So it explains and also really quickly points you to the right direction. So I love it. Let's have a look at the next example, and the next example is a performance problem, my favorite kind of problem. So I'll turn on the performance overlay, and I'll just go here, and it should be a pretty normal looking infinite list, right? But then at some point you see that, I don't know if you actually see the jank of the scrolling itself, but you can definitely see that spike there in the performance overlay, and that happens for some reason. And again, I might want to look at the code, but imagine the code is very complicated. I would love to find out what's going on through web tools. So Kenzie, how can web tools help here?
Yeah, so let's look at the timeline in DevTools to solve this problem. So here in the timeline, I have data loaded from the same app and scroll that Philip just showed. And I have a few different parts of this page to explain. So the top chart here is the Flutter frames chart, which basically takes all the timeline activity that's coming in from your Flutter application and breaks it down by Flutter frames. So you can see when you have a single janky frame or a single frame that maybe missed the budget that you need to hit in order to achieve a high frame rate of 60 FPS. And so for this example, we can see that there's clearly one culprit frame that is taking too long, and that's where we would probably want to look to find our performance problem. So if I select this frame, that's going to zoom these timeline events below to the timeline events that correspond to that frame that I selected. So in this chart, we have events that are asynchronous events, either from the Flutter framework or HTTP events that come in, or even events that you sent yourself from the Dart developer APIs. And then we have some synchronous events that also come in on either the Dart threads, the UI thread, or events that pertain to the raster portion of drawing a Flutter frame, so from the Flutter engine and similar like that. So for this example, we can see that it's the UI portion of the frame or the Dart code that's hogging the CPU and taking too much time. And we can obviously see that it's taking time, but we don't really have a good idea of what exactly is happening within this chunk of events that we need to solve in our application. So to solve this, we're actually going to use a feature called track widget builds. So I'll clear the timeline and enable this track widget builds feature. And basically what that does is when we are receiving events from the Flutter framework, it's actually sending events for each widget that was built during the time that the build portion of a Flutter frame is occurring. And so not only do we know, hey, the build time of this frame took a long time, we can then dig further into which specific widgets were being built. So here's the long frame again. I selected it and I'm zooming to these events in the chart. And it looks like we are building my expensive widget and it's taking quite a long time. And we have some normal widgets that are occurring, but these build times aren't really concerning. If I had to take a wild stab at it, I'd say that my expensive widget is probably our expensive widget. What do you think, Philip?
I forgot all about my expensive widget. It is a widget that, if you look at the code, is actually building a stack of normal widgets that is 100 items deep. So it's basically one normal widget, but 100 times overlaid on top of each other, which is not great for performance, and it's also totally absurd. But it's an again, I needed some example to show that even even things like that, even without looking at the code, Kenzie could find out, oh, there is a problem here, and it's called the widget is called something, and I can look through my code and see what's going on there, right? So that's super helpful. We should probably say that track widget builds is disabled by default for a reason. It takes resources for the profile like mode app to track all these widgets and their builds. So you don't want to have it on always, because it will make your profile build apps slower than they actually should be, and it interferes with your measurement and stuff like this. But it's really, really helpful to be able to open it up once in a while, or turn it on so simply in the DevTools, and then drill down to what exactly, which widgets take what time and what they contain. So that's super helpful. All right, let's have a look at the third problem, and I think our last. And look, it's another infinite scrolling view. And this one is actually janking all over the place. It's not just one widget there, but it's just generally not great. And as you can see here in the performance overlay, but maybe even just by looking at the scroll, it's not super smooth, right? So I would like to know what's going on there, and I can of course look at the actual code. So in this case, I have just a list view builder. That's great. I can look at the item and I see that this is all very innocent. Like you have container, row, size box, expanded text. Like there's nothing that could indicate that this this thing is slow in any way. And I could go deeper and deeper and read the whole thing, but again, it would be super nice if I could just look at DevTools and let it tell me where I should look first. So Kenzie, can you help with that?
Yeah, so this is an example where the timeline, though it is a performance tool, may not be the right performance tool for the problem. So here I have the recording again of the same thing Philip saw, and nothing is really jumping out to me that says, hey, this is a janky frame, you should look there, you're doing something expensive in a build method or whatever. There's nothing that's missing the 60 FPS budget that I can tell. So maybe the performance problem isn't a single frame. Maybe it's a problem that's happening across several frames. And to look at something like that, we'll just use a traditional CPU profiler to solve the problem. So what I'm going to do is start a recording. And I have the app right here again that Philip showed. I'm going to reproduce the same problem he saw. Stop the recording. And now I have a recorded CPU profile for the activity that happened during scrolling through that list. And I have this data in a variety of different views, the first of which is a flame chart. So this is a graphical representation or a visual representation of that CPU profile, where every single sample we took is what the call stack looked like at the time we sampled it. And so we can aggregate all that data to merge common samples and then help you identify hotspots within your application of, okay, this path was hit a lot. Something must be happening down there. So that's the flame chart. The same data as far as being top down is represented in the call tree. So we can identify expensive paths again. So, 68% of the samples in this profile started with a draw frame call, which seems pretty normal. I was scrolling through a list. So this will help us look at where the path is expensive, but we want a single method that's expensive, and we want to see where the CPU is spending its time. So for that, we're going to use the bottom up chart, where each one of these methods are the method that was on the top of the call stack when we took the sample. And so wherever that method, if we have multiple samples that have a shared method on the top of the call stack, that's a good indication that the CPU is spending a lot of time in that method. And here we can see we're spending 32% of the CPU's time in a method called Fibonacci, which I'm sure we can all take a stab and guess it's probably recursive. And we can see that here. It sure is, and it's taking a lot of time. So Philip, maybe look in your application for a method called Fibonacci and see if you're calling it where you should not be.
Oh yeah, yeah. It turns out I am actually using Fibonacci, but I want to show that even if I didn't know my code at all, just looking at the method name, I could just go and say, hey, what are the Fibonacci methods that I'm calling in my app? And there's actually two, but if I look at this one, it's actually in the same item line, and it turns out that I am computing Fibonacci numbers for every of these subtitles for no particular reason except to be terrible. So it's obviously not a good thing to do. I just want to again make a point here that even though this example may be absurd, there are other things that you as a developer want to do that are computationally expensive, and you sometimes do them in build methods without even realizing, right? Like you're parsing JSON, you're parsing Markdown, you're doing all this stuff that that might be like regex and stuff like this. From the top line view, it doesn't seem that there's any problem, and it's really hard to find out like, why is my app slow here? But if you look at the bottom up table, you can see, oh, it's actually, this particle method is taking this many milliseconds every frame. Where is it called from, and why? And then you can deal with it. So the way you would deal with this particular problem is just don't show Fibonacci numbers in subtitles, but in other places you could cache these things. You could pre-compute them before the user even comes here. But you can also kind of spread the work through different frames. So sometimes you do have to, I don't know, parse a little bit of something. Then you don't maybe need to parse all of it in one frame. And third, and probably the best option if it's really something computationally intensive, is just go and make that computation on a different thread. So use Dart isolates, and that's very easy. My computer almost fell down, but that's okay. I saved it. So yes, you can do this, and that it's very helpful to be able to look at the CPU profile. All right. So, Kenzie, I think we are almost at time. This is it. But could you show us some other things that DevTools can do for us?
Sure. So I've already showed some of the layout inspection tools as well as performance tools in DevTools, but we also have tools for a variety of other use cases, such as the memory page. So the memory page allows me to see a live view of both Dart and Android memory. So I got my native memory on the right and then the Dart memory over here on the left. And as I do things in my application, the memory increase will show in the graph, or as garbage collections happen, those will show in the graph as well. And I can take snapshots to get a live view of what my heap looks like at the time I took the snapshot. So what I just showed was a heat map view where we can zoom into the heap and check out what's going on and what's clogging the memory, or we can look at it in a table view and just kind of jump into the classes and objects that are allocated and how much space they're taking. So Philip showed earlier that each page is separated by a different gray page. So you can see we have 11 instances of a gray page and only one of the green page. So that reflects what we would expect. And then you can go even further and look at the instances to see if there's any notable information in those instances. So that's the memory page. We also have a network page, which collects HTTP requests that come in and allows us to inspect those to check out their headers, their properties for the response and request, as well as any timing data. So when was it initiated? When was it received? And, this is a lot easier than doing print debugging. So if I have a network request coming in and I want to check out the isolate ID, for example, okay, I can print that. But then what if I also want to see the content length? Well, I can print that too. But what if I also want to see the reason phrase? And you can use your imagination. It's printing a lot of properties for an object like this can be time consuming. And wouldn't it be nice if there's just a nice network inspector for you to look at all those properties in our tool? So that's what this is. So that is the memory page, the networking page, and then a couple other things to show. We have a full source level debugger. So I can set a breakpoint. I'll set a breakpoint here, which should be hit, and I can step over and in and through just as we'd expect. I can also look at the variables that are available at the breakpoint and inspect those properties and values. And I can see print logs that come in. Anything that's coming to the console will come directly to me. I can look up other classes and files in my code. So let's maybe look at the green screen. And here's the green screen in the app. And I can inspect that code and just read through the source there. Let's resume and get out of the debugger. And then we also have a logging view that listens for logs coming into your application, whether those are GC events or just regular console prints, or even logs that you've tagged yourself. So here's a log that Philip gave a special tag. The Flutter framework's not the only one that can make nice tagged logs. So he did that. And let's say I only want to see my network logs that come in. I can filter for those in this logging view and only see those requests. Or let's say I don't want to see anything from GC events. So I can do a negative filter and get rid of those. So that's kind of fun. Another thing to call out in this logging view is see these Flutter frame events. Because we're displaying this in Flutter and not just a console, we can do creative things like give you a visual representation of how long the frame took. So here's a Flutter frame that took 52 milliseconds to render and one that took 31. And so you can see the proportional difference between this bar visualization. So again, something that's just we were able to do in Flutter that was really easy and elegant and makes it hopefully easier for you to understand and read. So that's a brief overview. Hope that helps and gives you a good idea of what we have to offer.
Thanks. Okay, so I want to encourage everyone to go to flutter.dev and look at the DevTool documentation. There's a bunch of pages right here, so you should read all those. And but maybe more importantly, just like fire up DevTools, see what's new there, and try to play with it, because I guarantee you that you don't know about all of the things that are available, and many of them will be super useful at some point in your future. So all right, I think well, I want to thank you, Kenzie, for both showing us today what DevTools can do and for building these tools in the first place. And I want to thank you, audience, for watching.
Thank you.
Here we are again for another live Ask Flutter segment. With me this hour are Kenzie and Philip themselves. Thank you both for joining us.
Hello.
Thank you for having us. Hi.
Excellent. Kenzie, I noticed you were showing a lot of brand new things in DevTools that weren't in stable until very recently. You and the team did a lot of great work on them, but which new bit is your favorite?
That is a tough question. There's features on every page that are so new and improved from the previous version that it's hard to pick one. But if I had to, as a Flutter developer myself, one of the features that I have found the most useful is the layout explorer in the inspector, which we showed in the video. But just such a useful tool for building Flutter UIs and working with Flex widgets, understanding how to fix those render flex overflow errors, and definitely a tool that I use often and enjoy using. It makes my life easy. So.
Yep, absolutely. And Philip, it looks like you got your hands on the new bits as well. Was there anything that you found particularly useful in doing the Sloth app?
Oh yeah. So well, I mean, for the Sloth app, I basically designed it to cover the gamut of the DevTools. So it's there was no one thing that was especially useful, but I generally really like and that's not the most interesting, I guess, visually tab, but the network. I'm not sorry, not the network tab, but the CPU profile tab, and especially the bottom up thing that Kenzie showed has saved me many times, and it's been very useful. So I guess I'm grateful to that particular part of DevTools more than others.
Yeah, that absolutely makes sense. And that kind of gets into our first question a little bit, this is from Ask Flutter on Twitter that we did over the last couple of weeks. We have Wilson from Nigeria asking how they can boost the performance of their Flutter web projects. And Kenzie, I'm interested in your take first, since the DevTools are kind of a Flutter project. What did you look at for boosting that performance?
So one thing we did to boost our performance was to make sure we're using a Canvas kit enabled build. So you can pass a flag to your build, a Dart flag that enables the Canvas kit Skia backend for drawing your scenes in your app. And that really has helped our performance. Though I will say the Canvas kit is it's an alpha, beta, whatever you want to call it, project. So it's not completely bug free, right? But the team's great about iterating on issues we find and solving them, and so it's been really useful for us. We mostly develop on Flutter desktop, to be honest, because it's just nice, and hot reload is great. So but yeah, when we go to ship, we ship for web, so we got to make sure that is performant as well.
Makes sense.
I just want to say, so I guess we should say Canvas Kit is basically Skia running in the web browser through WebAssembly. So it's cool just in general, right? But yeah, Flutter uses it, and you can pass a flag, and it makes it run faster. I just want to say to the original question, generally you have to expect Flutter to be running slower on the web, and that's just a reality. To be honest, maybe a better way to put it is Flutter runs really, really fast when you're running on desktop or mobile, like natively, and it's very hard to replicate it, I guess, on the web, because there's always this overhead, right? Like even if you only do Skia like through Canvas Kit, you're still running in the web browser, and you still have to do all this other stuff, and so it makes it harder to do everything fast. So we should kind of set this expectation, right? Like it is really hard to make anything like this performant, and Flutter is performant, like really, really performant. If you think about it, like if you're scrolling a list in Flutter, it will relay out like 60 frames per second. It will actually like rebuild your tree, right? And that's expensive, but like Dart and Flutter make it look like it's very easy and fast, because they can compile to native code and everything like that. But on the web, that's like there's definitely an overhead. So I guess what I'm saying is, make your apps, probably if you're targeting the web, make your apps a little less complex, and you can definitely do that. Like there's a compile time constant called k is web, which you can just check, and you can be like, oh, I'm on the web. Maybe I don't need this fancy little animation or like a shadow effect or something like this. And that
maybe I don't need Fibonacci numbers in my list.
Yes, and so no, you always need Fibonacci numbers, but like the rest, you can just don't do that. And I'll also say, because it's a compile time constant, it will be compiled away, it will be tree shaken away, that code will not be even there in JavaScript. So win-win.
Awesome. So I have a compliment from the audience, and then a question for you, Philip, to follow up on that. So Philippe is saying that they love to hear you talk, and that you seem to be a very nice guy, and that they love your accent.
I am a very nice guy. Yeah.
I can confirm that as well. Philip is a very nice guy. Kenzie is also very nice as well.
Hey, I love Philip's accent too. I think it's great.
Yes, exactly. So that was the comment from the live stream. But the question is one of our Twitter questions from before. Daniel in Hungary asked, how can we check code coverage of tests? It's kind of tooly, kind of performance-y, because we want to be able to test things. And so Philip, I'm interested, how do you check coverage of tests?
Yes. So that's actually well, there's good news and bad news. What do you want to hear first? I guess the good news is that there is coverage, and you can just Flutter test -- coverage, and you can take it will generate the LCOV file, and then you can for example, send it to coverlogs.io, which is like the CI, like continuous integration service, which, for example, Flutter itself uses. So you can go to coveralls for Flutter and see how like the graph goes up or down. It goes up for Flutter in terms of coverage. We should probably also say that what like test coverage is, right? So some people may not know this. So it's basically what percentage of your files and source code are covered by tests, and like you don't want to have like a 20% coverage. You want to be in like the 70, 80, 90%. Nobody's 100%, I don't think. But yeah, so we have all that for like your CI/CD, so continuous integration. We have all that. I actually tried it, I think 2 weeks ago, and I got pretty far, but not all the way there, where you can take the LCOV file and like put it into a plugin in VS Code, and it will actually do the right thing. But the bad news is that this does not happen automatically, not in IntelliJ and not in VS Code. We do have a thing for like just Dart. Like if you just run a Dart program, we can show you the code coverage, but not for tests, which is kind of not good. So, but unless I mean, I'm pretty sure the feature request is there. If not, then please file it. I will definitely +1 that request, and everyone should go there and +1 it as well, and then we'll have it.
Cool. Kenzie, anything to add on test coverage, or did Philip cover it all?
I think Philip just hit the nail on the head as usual. I don't have anything to add there.
Excellent. So when you all were demoing the Layout Explorer, there was one bit where you can either use like an expanded or a flexible to change how the containers and how the items within the containers are being sized within those containers. And so we have a question here from Aravind, who is asking, what is the difference between expanded and flexible? They kind of show up in similar contexts. So Kenzie, I'm wondering if you have some insight for us on what is the difference?
Without looking at the API, I'm pretty positive expanded is just a flexible with a default of 1. So if I am writing a build method and I want one item to take up the rest of the space, I'll typically wrap it in an expanded. If I have multiple items that I want to split, I don't know, like 60, 20, 20 or something, I can wrap them all in a flexible and give them flex values that reflect how I want the row or column to be split up. I don't know, Philip, if you have anything else to add.
Yeah, I'll just add to that expanded actually forces the child to go all the way and fill the available space, while flexible just kind of like that doesn't force it. So it's like if the child says, "Oh, I'm fine with 50 pixels," then it's fine. But expanded is like, no, you're going all the way. So that's the difference, I think.
Yeah, I think that's right based on my recollection as well. But you all are the experts. So, but this notion of sizing and things relates to this next question, which is from Grisha, who is asking, are you planning to add widget size inspector to the Flutter inspector? They're saying it would be easier to check exact UI sizes and not render object properties, but maybe on hover or something using the inspector and the tools we provide there to select the widget and whatnot. Can we see the widget size there? Is that something we're working on?
Yeah, I would also absolutely love that feature. So it's not currently available, but definitely something that we want to do. And when, like Philip said, when it comes to prioritizing what we work on, if you file an issue and get a bunch of thumbs up, that's a good indication for us that, hey, people really want this. And, that can help us prioritize what we work on. But I agree, that would be very useful.
Yeah, me too.
Yeah, me 3. It'd be very useful. So 3 thumbs up already. File the issue and you'll get 3 immediately. So coming back a little bit to this idea of performance, and maybe Philip, you experienced this when you were throwing all kinds of performance issues into the Sloth app. Jeremy is asking that they say, hey, my app is very shadow heavy and spending a lot of time doing rastering. How can I speed things up? So they've got a lot of shadows and it's kind of running slow. What advice do you have for Jeremy?
Yeah, that's tough. Shadows are generally hard and performance intensive. So it would require to look like closely at the code and see what you can do. Some apps will just literally like you know that you can just wrap anything with a widget and kind of take a picture of it, and just like cache it and then put it back, right? So one way to do this is really just like cache this shadow if it's not changing, right? Or do some other way to just like make it very easy, or hopefully avoid computing the shadow on every frame, or computing a shadow over a shadow, which is, so there's no single way to fix this, but there are ways.
Kenzie, any thoughts on fixing shadows?
Shadows are actually something I haven't personally worked a ton with, just because we are really concerned with performance for DevTools. We're already doing a lot of like complex animations and zooming and all these 2D lazy rendering things. So we, other than like making useful animations, I don't know that we've really ventured into the world of shadows yet. So yes, I second +1 to what Philip said.
Fair enough. And let's see, looking at our live questions. So Carlos from Chile is asking, and Kenzie, I think as one of the engineers on the DevTools, I think you might be the best to answer this one. Is there an easy way to implement those changes that were made in the Layout Explorer just in your code?
Yeah, so it depends what change you make, right? If you're changing the cross-axis alignment or main axis alignment, then that is just the name of the property on the row or the column, and you can add it there. If you are changing a flex value, like Philip showed, he had to wrap his widget in a flexible or in an expanded if that ends up being your solution. So I guess just kind of understanding how flex affects your widgets and being able to wrap it in that flexible or that expanded. In the future, we'd like to revamp and improve the Layout Explorer so that maybe you could hit a button that says like, okay, apply changes, and then we change your code for you. And that would be great and easy on you. So that's some improvements that we'd like to do in the future. Again, file an issue and get lots of likes and we'll do it.
Yeah, cool.
Yeah, I think +1. I don't know, but yeah. So far, whatever I've gotten from the Layout Explorer was in the end was basically wrapping something with an expanded or flexible, and then all good.
Thumbs up, you're good. So kind of bouncing back and forth between layouty things and performance. And so one common question I see about performance, and I'm interested on both of your takes, I think starting with Kenzie and then we'll get Philip. Ayush in India is asking, how do we reduce the app size in release? So sometimes app sizes can trend a little bit on the larger side than we'd want. How do we take it down?
So that's a good question. Also one that's pretty dependent upon your specific app. So we are actually working on a tool right now. An intern on our team is actually building a code size debugging tool, and we're hoping to add that to DevTools so that you can look at a compiled AOT or a snapshot from the AOT compiler. And analyze the size of all the packages in your application. And maybe you have a package, you pulled in a package that you didn't think was going to take up as much space as it is. And maybe you're only using one small thing from that package. So you could rethink whether you want to pull it all in or if you want to, implement something yourself. So again, really depends on your app, but we're hoping to provide you with tools to dig into that soon.
Yeah, for sure. And also, I guess we should say that I think Flutter is right now at about like 6.5 max that you will have no matter what, which you should be aware of. Like if you want to make an app that is 500 kilobytes big, then Flutter is not for you. Flutter, brings with it the rendering engine and like text rendering engine, everything. So you should not be expecting that. On the other hand, so I'm kind of assuming that you're like in the range of like, oh, my app is like 100 max, and that is either a really big app, which we've seen in the wild, and that can be a problem, and like code can be a problem. You have too much code. But if it's like your app is not hundreds of thousands of lines of code, then most probably the size is coming from assets. And for that, I would just say that we have support for flavors. So we have support for like saying, hey, this app, like for example, I don't know, like this flavor of the app is for this market. I don't need all the language packs to be bundled with it. Or maybe there's I don't know, like a huge amount of pictures that I can have in one flavor but not in another, and stuff like this. It's if you just search for flavors on Flutter Dev or in generally on the internet, you can find how to set it up.
Yeah. So what I'm hearing from both of you is that it really does depend a lot on a variety of things. And so like one strategy might be to offload the images to be loaded later and loaded more dynamically from a backend server if you have that option. And if that option is available, it just really depends on your app and what you're doing in the app and what you need people to see immediately versus having that little bit of a network delay is okay. And that's really up to you as the app developer.
Yeah, it's very easy to kind of drop in your images into the assets folder and kind of like be, oh, okay, so they are there, and I'm fine. But like in generally, often you will actually not use the full resolution of those pictures, and that's also, it's not only a problem in terms of memory and the size of your app, but it's also a problem in performance, because if you're resizing, like if you have like a huge 2 meg image and then you resize it for a thumbnail and show it show a 7 of them on every scroll, then that's going to be a lot of work that you're doing in Flutter, or Flutter is doing for you, but you're using CPU and battery for basically nothing. So yeah, have a good look at your assets.
Yeah. So stepping out of performance and layout and tooling for a second, I have to ask a question that everyone is asking, which is, what do you recommend for state management in 2020? It's the question of the day for every day. So Kenzie, actually for the DevTools rewritten in Flutter, what was your approach for state management?
So yeah, I can say what we did. I don't know if it's what we're gonna just slap a label on as best practice, but it's worked really well for us. We use a lot of value notifiers and value listenable builders. So we keep our code, or we have kept it pretty well contained to kind of like a view controller model. And so the controller will have all of these notifiers, which we listen to from our UI code. So in that value listenable builder. And this has worked well for us because we don't do a lot of dynamic data stuff with dynamic data. Like there's not really a ton of user input or data changing that we'd need like a closer handle on the state. So we pull a lot of data from a running Dart VM, and then that's just the data. And like your CPU profile is not going to magically change until we pull another one. So it's worked really well for us. I don't know, the pattern you use may be different if you're doing a lot of like user input type stuff, but I can say what's worked well for us.
Yeah. Well, yeah, that's the thing, right? Like by the way, so I still recommend Provider for most cases, just because it's very close to the metal. It's very close to the, value notifier and everything like that. It's basically a wrapper around the inherited widget and change notifier. And it kind of works for many cases, even for bigger apps, some of them. But that's the thing is that with Flutter, a lot of what you're doing is state management. Like because building UI in Flutter is so easy, a lot of what you're doing is building features and just like building logic, which is almost all of it is state management, right? And we have such a variety of apps as well, right? Like we have everything from business form heavy applications to like cute clock faces and games and everything between. And so it's very hard to say like, yeah, this is the state management of Flutter, because it will be very different for these three things, right? And so some people say, hey, like it would be really cool if you were more direct and say, hey, so what should we use? And I think I can see the frustration, and I can see that it's hard for people to decide and stuff like this. But I don't think it's a good idea to be more direct, because then you're kind of forcing everyone on the same level, and you're kind of you're forgetting that variety in Flutter. And we see that there are apps that are very successful, and they chose all these different techniques. It's not like there's an app that's written in not Provider and it's doing really badly. It's not like that. It's just like people have good reasons to choose the state management approach that they chose, and it works for them. So Provider is what you should do if you're not sure. But if you have any other reason to use something else, you should not be afraid to do that. And always know that this is like the majority of the. It is hard, and it will always be hard, and it is the majority of the things that you will be doing with Flutter, because that's basically building your app is state management.
Yeah,
I'll add
makes
to
sense.
that.
Go ahead.
Oh, sorry, Fitz. I was gonna say I'll add too that we do use Package Provider as well to handle a lot of like those top level objects that you want available everywhere in your application. For us, like notifications and controllers and stuff like that. So definitely useful package there.
Yep. And I think the high level answer I took away from both of you is, again, it depends.
Isn't that an answer for everything? Like,
yeah, we could just go all the way down
Yeah.
these questions and answer it depends, and then we'll be done, and it'll be a great Ask Flutter session.
That's the true one size fits all answer that we have.
Yes, exactly. So I have a couple of really quick questions left for you both. So a first one, just PWA versus Flutter. So progressive web app versus Flutter. Philip first. Which one or both?
Oh, so ideally both, because
Okay.
Flutter can do a PWA, but I mean, not ideally. What I'm saying. So if you're really like if you're focusing on a PWA, and you really want some, like, especially if it's like very content heavy and you don't need all the bells and whistles of Flutter, just go with PWA, progressive web app. If you're, I think the best use of Flutter for web right now is you have an app and you need to, like, you want to be able to provide a part of it or all of it on the web, right? It's like also another target. But if you're building for the web, there's probably a good other option out there that could be helpful.
Okay.
Plus
Kenzie,
one.
it depends.
It depends.
Yeah,
plus one.
So for this last and final question, I want a one-word answer from both of you. Kenzie first. If you took a Flutter app and replaced each of its widgets one by one until they were all replaced, would it still be the same app?
All the widgets with a single widget?
Each widget one by one. So they've all been replaced.
Oh. Depends on the state, I guess.
Yeah, it depends. Philip?
Depends.
Yeah.
Just no. Generally, just no.
just no. Okay. All right. Well, thank you both for being with us again. That's all the time we've got for questions in this segment. Thank you again, Kenzie and Philip.
Thanks for having us.
Thank you.
All right, and thank you all for watching. Before we sign off, I have a couple of reminders. Check out the Flutter Day website at g.co/flutterday for all of the information about the day. Code labs, schedules, meetups, maybe some puzzle pieces. And there are multiple opportunities for you to interact with other people, learning and helping others learn Flutter. As you get more familiar with things, it can be easy to forget what it felt like when you weren't familiar with things. They're not always obvious until you've already seen them, so my hope is that everyone approaches questions from others with curiosity rather than judgment and supports each other. Finally, Hack20's site is now open for registration. Head over to flutterhackathon.com, possibly with a hard refresh, to sign up. Our third and final segment centered on Dart and null safety is up in about 11 hours, and we will see you there. Thanks.